Howdy, HL, it's Miss Kosh. I wanted to work through the example in the book because it shows up in other places, and I thought this might be helpful to talk through it with you. So the book says something like, let sine x minus root 3 cosine x equal k times cosine of x plus b. So what this is enabling us to do is it's giving us, if you notice right here, this is something we would know how to graph. Okay, if you think about that, its amplitude is k, and it's been shifted. I guess that's technically it's been shifted to the left b units. So if you notice here in Desmos, I've graphed that, and I'm trying to see, okay. I haven't graphed the k cosine x plus b because I don't have any values to put in them yet. So I'm trying to figure out, okay, what k value, what b value, oh my goodness, that's out of control, is going to match the graph that I get when I have the red graph, okay? If you think about it, I don't know how to graph the top equation, the one in red, without either plugging in points, or I just don't have a natural way to do that. So what we're going to do is we're going to try and figure out, well, if I were given that top equation, is there a way that I could graph it by hand? Okay, so that's one of the things, and I just think it's fun watching these waves, so I'm easily amused. All right, so let's jump in and see what we have. Well, so what we need to consider is, okay, so we've got this sine of x minus root 3 cosine of x is equal to, well, k times cosine of x plus b. Well, we have now learned that this is equal to cosine, opposite SIGN, sine, if we were to expand that out. Okay, and so now what we have is well, sine of x minus root 3 cosine of x is equal to, let's put the term with sine in front. So my goal is to have the sine term here match this. The sine of x match the sine of x, and then the cosine would be the second thing, so that those two would match. That's what I'm going for. So I have a negative k sine b times sine of x, or maybe, you know what? Let's change that up. Let's put the parentheses. Not that we need parentheses, but I'm putting them here on purpose. Okay, and then we also have, so this multiplied by that is now here. Let me make sure I didn't mess up, because sometimes I do. Okay, I think we're good. And so then I also have a positive, let's do the same idea, k cosine b times cosine of x right here. Well, so now what do we have? Well, we have that this term, sine of x, is going to need to match that term. And let's pick a new color. This term is going to need to match that term. So what we have is that, well, the coefficient of sine of x is 1 is equal to negative k sine of b. And we have a negative root 3 would be equal to a k cosine of b. Okay, and those two would imply, what we can do is we could solve for sine of b, and that would equal, well, it's a negative 1 over k. And cosine of b would be equal to a negative root 3 over k. Okay, and then what the book does next, and you've got a few choices. You're trying to. We've got two equations and two variables, so we can solve it. But what the book suggested, and I thought was clever, is that tangent would be equal to sine over cosine. Okay, and so now our sine value is negative 1 over k, and our cosine value is negative root 3 over k. I'm sorry that gets bumpy. But now, okay, I keep saying, but now I'm so excited. So what we see here, if I multiply by k over k, which is our favorite letter, by the way, I end up getting that the tangent of b is equal to, well, a positive 1 over root 3, which we're more familiar with saying, well, that's root 3 over 3. Okay, this automatically takes me back to my unit circle, and the unit circle never goes away. And if you remember, my tangent, I'm looking at slope, and so this is when slope was 1. Here, slope is undefined. I'm too lazy to write it out. Here is slope equals 0. This, and then the question is, one of them is root 3, the other is root 3 divided by 3. Root 3 is a bigger number than root 3 divided by 3, so that's a steeper slope than this one. Okay, so what we find is that we want this angle right here on the unit circle, which is pi over 6. So let's go ahead and say b is equal to pi over 6 plus, but since it's tangent, we're going to say pi k. Okay, so now we have, well, okay, another thing I want to point out. They're telling us that b needs to be between 0 and 2 pi. Well, if we think about the unit circle, we now know that b is either, b could be pi over 6 or 7 pi over 6, and we need to verify which one of those two it is. So what I think we should do is come back to one of these original equations, plug in our two b values and see, first of all, what is k, and then verify that k actually meets this requirement. Okay, so, never mind. All right, it was funny in my head. So I have this negative k sine of b is equal to positive 1. Let's try, we're gonna try both. We're gonna let b equal pi over 6. So negative k times sine of pi over 6 equals 1. And this is sine of pi over 6 is 1/2. So negative k times 1/2 is equal to 1. Multiply both sides by negative 2 to get k by itself, and I get k equals negative 2. But notice that one didn't work because we said that k had to be positive. So we don't want to use that one. So the other option was to say negative k sine of 7 pi over 6 is equal to 1. This is negative k times 7 pi over 6. That's down here. This is a negative 1/2. Do you see how I see the unit circle in my head? So this is a negative 1/2 equals 1. So I need to just multiply by positive 2. So k is equal to positive 2. And that is better. So notice, what do we have here? We have that b is equal to 7 pi over 6 and k is equal to 2. Well, so now let's go check on Desmos. Let's see what happens when I use k equals to 2. Okay, stop the insanity. Let's type that in. I stopped some of the insanity. Okay, k equals 2. That's good. And then what did we just say? 7 pi over 6, if I'm remembering correctly. 7 pi over 6. Oh, look at that. How cool is that? Here are those two graphs. They match up exactly. So, you wouldn't necessarily have Desmos on a non-calculator part of the test or your calculator on a non-calculator part, but as you're practicing, this is a great way to verify that you got the right answer. And I was just working one of the problems that I put on that really long worksheet, and I had gotten the wrong answer, and I was struggling, and I didn't know why I was wrong. Desmos told me I was wrong, and then I realized that I went to go back and check, and my problem I got the sine or cosine wrong in my problem, and then I was like, oh, I was right. I just typed it in wrong on Desmos. It was frustrating, but I solved my problem. All right, I hope that was helpful.